by Murad Wagh, who is the Director Sales Engineering India with Snowflake. To give you a background, he is currently leading a team of talented sales engineers responsible for pre-sales function at Snowflake India. He comes with wealth of experience, skill sets around data center automation, virtualization, cloud technologies, infrastructure management, cross-management domain architectures, and team management. Can we welcome Murad with big round of applause, please?
Good morning, everyone. All right. I think we have a fantastic flow where Vimal started off talking about 𝗙𝘂𝗁𝗏 data strategy hai, and then Viraj followed it up with a fabulous take on what a data strategy should look like. Over the next 30 minutes, I'm going to talk about what Vimal started off with, the data cloud, go a little deeper, talk about what we believe are the 7 tenets of what a modern data platform or a data cloud should look like. A few legal disclaimers, because possibly there'll be content that talks about roadmap or future-looking statements, so it's important to note this, and we'll get into the topic. So before we talk about the 7 tenets, right, we'll take a little bit of peek into history in terms of how Snowflake started, what we started doing. So right from the beginning, even before we went GA out into the public with our product, the idea was to disrupt analytics. This was the time of big data. The ability to churn data, deliver insightful analytics was super critical. And the founders of our company figured that it is difficult for existing traditional systems to do that. So they came up with an architecture that was built for the cloud to take advantage of cloud scale. They decoupled storage, compute, all the goodness of an elegant architecture, and they came up with the Snowflake architecture or platform, which disrupted the way analytics was done on the cloud, the way it scaled out, the way it gave access to data to everyone today, what we call data democratization. Come 2018, we said we'll disrupt collaboration, because we believed that the way data was being mobilized, the way data was being shared, was using mechanisms like FTP, which itself is a 50-year-old technology. And we all understand it is brittle, because if I want to share data with my partners, with my suppliers, or anyone who needs to consume that data, I have to build a pipeline. And it could break, it could have an error. By the time someone gets access to that data, it is stale. So we said we are going to disrupt collaboration by making that data instantly available to the target user or the consumer, right? And not just that, we said you could share your data, but you could also start consuming data via what we call the Snowflake data marketplace. And that is something that I'm going to cover in terms of how could you leverage third-party data instantly and in a secured manner. Not just that, how could you take your data and start thinking about monetizing it on the data marketplace. And today what we have done is we've taken all of that and we've focused our innovation on disrupting app development. The way apps are developed today, the way they leverage data, getting relevant data points very quickly accessible to delivering insights for your data models, for analytics, so on and so forth, is what we are focusing on today. Having said that, Vimal spoke about the data cloud. He spoke about different organizations being able to share data. In very simple words, I would define a data cloud as an architecture that allows you to mobilize your data. Your data can no longer afford to sit within the 4 walls of your organization. It needs to step out. It needs to be made available to consumers that need it, right? And these consumers could be within your organization, they could be outside. These could be your partners, suppliers, your customers, and making this data available to them is the entire objective of the Snowflake Data Cloud. And obviously, having the ability to do this at scale, very quickly, and in a secure manner are the fundamental tenets of building the data cloud. Now, before I get into talking about those 7 tenets, we'll talk a little bit about the core platform that drives the data cloud. And this is it. We just have one product, one platform with the ability to run multiple data workloads. And I'll get into what a workload really means as we go through. But this platform is something that was built for scale. It was built only for cloud. So we get a lot of customers coming back saying, you know what, we are a highly regulated industry, and do you have an on-prem version of this? The answer is no, we don't, because this is something that was built to take advantage of the cloud. By the way, it's multi-cloud, which means it's available on the most popular public cloud environments, the hyperscalers, that's AWS, Azure, and GCP. It's a platform that scales. It's a platform which has got a very elegant and sophisticated architecture. And the most important part is that the infrastructure or the platform is completely managed by Snowflake. So as a consumer, you're focused on making sure that the data is made available to teams that need it. Rather than managing infrastructure, rather than managing the data itself, you just focused on making sure the data is made available to the consumers, right? It's got what we call a very interesting elastic performance engine. In very simple words, compute that is available to you when you need it. And remember, this is on the cloud. So you don't need to keep your compute pre-provisioned all the time. If you need compute now, you just switch it on, it switches on, does the work, and then you may choose to suspend it. And you pay for exactly what you consume. It's got the ability to scale up, it's got the ability to scale out on demand. And then there's this very interesting thing called a snow grid, which is what I'm going to talk about. That's one of the key differentiators of the platform. Now again, if you look at our lineage, this started off as a cloud-based data warehouse. But very quickly we realized that there are other data workloads that need to run on the same platform, because we started off saying we want to solve the problem of data silos, right? So we don't want a lake there and a warehouse here and then complex pipelines feeding data into each other. We said we'll get data, all of it, into one place, and that place has got to be scalable. And then we run a data warehouse, a data lake, data science models, data applications, data engineering, all of that on one single copy of data. And that's what we pride ourselves on, right? So you break down silos, you get data into one place, and make sure it's accessible to everyone that needs it. All right, let's start talking about those tenets that I spoke about, right? The first one is what I was speaking about, all workloads. So you think of data, you start thinking about what can I do with this data, and this is where you start thinking about all types of data workloads, right? Could be a data lake, a data warehouse, data engineering stuff that I spoke about. There are a few more that we've added, and I'm going to talk about it. Any number of workloads. So you're no longer restricted by physical infrastructure that sits in your data center that says you can run a data warehouse only for this scale. If you need more, you need to add more nodes, and that takes another 4 months, right? Gone are those days. You can scale this instantly for any number of workloads, and very importantly, any concurrency. Because today, data workloads are not fixed by nature. You could require a very small compute engine to train a particular model, but when you put that model into production, you will require maybe 4 times the same compute power. Now, what are you going to pre-provision? With Snowflake, you don't need to pre-provision, right? So it takes care of concurrency, it takes care of scaling up, right? So we'll talk about the workloads. This is what I spoke about. The data warehouse, the data lake, they're there, they're ubiquitous, they existed for a long time, and they're still very, very popular. Today, we see a lot of organizations with on-premise infrastructure supporting these workloads, wanting to move onto the cloud for valid reasons, saying, here's the scale, here's the elasticity, here's the performance that I need, and only the cloud can afford to give that to me, right? So that is one of the reasons why they migrate to the cloud. But then there are other workloads like data engineering. How do you build robust pipelines to get data from the source to the consumer flowing through in minimal time, right? That's all about data engineering with all your validation checks, your transformations done in between, so on and so forth. Data science, AI, ML, we just heard about it, very, very popular, right? And that's a very different stream from the way analytics is done. And we'll talk about that a little later as well, but remember, data science, Python, model training, all of these capabilities are now supported with Snowflake as well, using a language of your choice. Then there are applications that are built on top of the platform. You can build applications, you can build application logic, but you can leave all of the data heavy lifting back to the platform. That is what we do best, right? And you build your applications around that. In fact, we've got a program called Powered by Snowflake, where partners can choose to build their own applications and leave the data heavy lifting to Snowflake, and then ship out the entire application along with the Snowflake platform. Then there's data collaboration. It's all about how do I expose my data in a governed and a secure manner to external entities that need to access it without getting into the complexities of building pipelines, FTPs, monitoring it, so on and so forth, right? So there's a very different way and an elegant manner in which data can be shared. We've also added 2 more workloads this year, one around cybersecurity and the other one is what we call Unistore. Now, cybersecurity is interesting because if you talk to your CISO or your infrastructure teams, you'll figure out that typically that's a separate silo for a very, very long time, right? They've been looking at logs from different devices, applications, systems, and consolidating that into one place so that they can do activities like threat hunting, incident response, so on and so forth. Unfortunately, and fortunately, there are a lot of regulations today that mandate storage of those logs for a particular period. And they're facing problems. These departments are facing problems when it comes to scale, performance, the ability to quickly react and respond to security incidents, which is where we saw this as an opportunity to help customers to build what we call a security data lake. So essentially, all of your security information, cybersecurity logs, events flow into one place, which is Snowflake. Remember, it's one common place for you to hold all of your data. Now imagine you can take your security data and start thinking about joining it with your business data to get context, right? And the same powerful governance capabilities, the compute engine, the storage of the Snowflake platform are applicable to the cybersecurity data lake as well. And then we partner with the likes of SecureOnyx, Panther, Hunters, and so on to provide an XDR or an SIEM layer on top, right? The other workload is what we call Unistore. Now this is interesting because for a long time since inception, we've been an analytics platform, right? And we all understand, I don't need to get down to basics, but there's OLAP or analytics and then there is transactional data. Now traditionally what we have done is transactional data belongs to an application from where we pull out that data and put it into an analytical system using pipelines. And therein lies one of the most complex problems that organizations are trying to solve today. The issue of pipelines feeding data into a common system. We said we'll solve that. We said that within Snowflake, we will run a transactional database, and that is what we call Unistore. More on that later because this is something that we just announced, but it is exciting times because now you can run your transactional databases right inside Snowflake and get your data accessible then and there without having to build pipelines to feed into an analytical system. We'll talk about tenet number 2, which is data, right? Because workloads are okay, but finally it's all about data. So what are we talking about data? The first thing is all types of data. And I like what I just heard in the previous session, right? We typically think about warehouses as more about structured data. But I like the fact where you said that less than 1% of data being analyzed today is unstructured data. And we all understand the potential of unstructured data. So think of data as structured, semi-structured, unstructured. Social media feed, images, documents, videos, all of that data without having to keep it in different silos, file folders, FTP sites, getting all of that into one place so that it is accessible to all the consumers that ever need access to that data. So that is the different types of data. All sizes, like I said, this is on the cloud, so you can start really, really small. You can start with gigabytes of data and very quickly have the ability to scale that to petabytes, multiple petabytes of data. And we've got large customers running petabytes of data inside their Snowflake warehouse and running queries efficiently across those databases and tables. And then we speak about all origins. I briefly covered this initially when I spoke about data that belongs to you, which is what we call first-party data. Then there's second-party data that belongs to your suppliers, partners that gets fed in via various mechanisms today, but how do you get access to that data? And then very importantly, third-party data via what we call the Snowflake data marketplace. So regardless of the origin of data, can I have that data accessible in one place? That is what the platform is all about. Now we realize that while we operate on the cloud and get access to data that sits on the cloud via data pipelines, it's equally important for us to realize that there could be certain sensitive industries that choose to keep their data on premise, but they want the goodness and the scale and the elasticity and the governance of a cloud-based warehouse. So we said we will announce a capability for us to access data that sits on premise. Access that data, and then the control plane is still on the cloud, right? So you get all the goodness of the compute, the rest of the Snowflake platform, but the data can sit on-prem in a supported object storage, which is S3 compliant. We made that announcement with Dell and Pure Storage, but suppliers are free as long as they have S3 storage or S3 compliant storage to start building these integrations with Snowflake. So that's one announcement that we made. The other one is about supporting open formats, right? A lot of customers choose to use external tables for good reasons, right? They may not want to keep all data inside Snowflake, and there are some standards when you store that data external to Snowflake. One of them is a very, very popular format called Apache Iceberg, and that is what we've announced support for. Apache Iceberg is an open source project. It's got a very vibrant community today. It started off inside Netflix, but then they decided to open it up. Very, very high performance, stable format, and that is something that Snowflake will now support. Essentially, the data sits outside of Snowflake, but you can access that data, provide all the governance capabilities, the compute, query that data as if it sits inside Snowflake with very, very similar performance as you would see with regular Snowflake data, right? So that's the capability to support Iceberg using a capability called new Iceberg tables. Then we talk about governance. This is super critical because, again, when we talk to a lot of regulated industries that are governed by regulators, they talk to us about, we're going to keep our most sensitive data on the cloud. So talk to us about your governance capabilities. This is a managed platform. How do you manage your platform? How do you manage incidents, so on and so forth, right? So this is a very critical topic. We take it very, very seriously. So a few examples. Data that gets onto Snowflake by default is encrypted. There's no option to switch it off, right? In addition to that, as a customer, if you're in a regulated industry, you could choose to bring your own key to augment the key that is already generated for you. So this is a BYOK, bring your own key concept, right? Where you can just lock in that data. Any data that travels via a Snowflake connector or a driver is again encrypted by default. And then there are tons of capabilities inside the platform that allow you to protect the data that you keep on the platform itself. For example, there's row-based access control, there's masking, all of those capabilities from a security standpoint are included as part of the platform. But if I'm to define what governance really means in 3 simple steps, right? Why do you do governance? You want to make sure, and again, I go back to your presentation where you spoke about centralized, decentralized, how much of freedom do you want to give versus the control, right? I want that freedom. I want the ability to unlock my data. I want the ability to start thinking about monetizing my data. But before I do that, I need to be convinced that the data that I have is secure enough, right? So we start this cycle with knowing your data, the ability to classify that data, the ability to tag that data saying, this table is containing PII data. So when I expose it, by default, certain columns are masked, right? That is the level of automation that we're talking about. Once you know your data, you know what is stored, where is it stored, who's accessing it, then you start thinking of how do I protect this data? How do I control? Row-based masking, column-based controls, role-based access controls, and automating all of these policies. For example, Snowflake, we heard about the data cloud, right? It can make your data available in any cloud, in any region. Now, when that data is made available from one region to another, how do I make sure that the policies that I applied here also get applied to wherever the data moves? And that is exactly what the platform allows you to do. It makes sure that your policies applied in one place get applied everywhere. It literally follows the data. And then once I do that, I know my data and I've protected my data. That is where I have the peace of mind and the confidence to start unlocking my data and unlocking the potential of that data, right? So governance is a very, very key component of what we do at Snowflake. Then we talk about the global reach of the platform. Now, while there are certain organizations that are governed by law to maintain data sovereignty and keep the data in India, today Snowflake is a global platform. It is cross-cloud, it is cross-region as well. And remember, I'm using the term cross-cloud and not multi-cloud. And there's a difference, a subtle difference, and I'll talk about that as we go through. Snowflake is available across multiple regions of different cloud providers across the globe. Now, the key difference between multi-cloud and cross-cloud is multi-cloud means that I'm available on multiple clouds, which we are, right? But cross-cloud is taking it one step further, where all of these different regions are connected via a network that is built by Snowflake, leveraging the hyperscalers to make sure data is mobilized. So it is not just multi-cloud, it is cross-cloud, which means your data, if it is sitting on, let us say, AWS Mumbai, and you want to make sure it is available in your offices in Europe so that they get low latency access, it is just made available without having to think about the plumbing, the underlying network, how do I replicate this, so on and so forth. Another classic use case for this is the ability to do business continuity planning, or BCP, or DR as we call it, right? The ability to do it across clouds. Believe me, it is super complex to do it across different clouds because each one has their own compute, they have their own storage. We mask away all of that complexity. We decouple the hyperscaler infrastructure and put in a layer of the Snowflake snow grid so that your data can be replicated. Not just that, it can be failed over. Your clients would start connecting to that copy of data, and then you have the ability to fail back. All of this can be completely automated and done at the Snowflake level, right? So this is a global cross-cloud capability that the platform allows you to do. Again, these are things that are completely automated and delivered as a service, so you don't have to start doing the plumbing. Again, you're focused on data and not the plumbing. Then we talk about the platform itself being self-managed. And this is, again, very, very critical, where we talk to a lot of customers today where they are dealing with on-premise systems, and I think most of us come from that world where we've dealt with servers, operating systems, applications, patching, upgrades, all of that stuff, right? And when you think on-premise, those things do come into play, which takes away a lot of time. And you want to be focused on data. We heard through the previous presentations about data strategy, what can you do with data, but here you're spending 60% of your time just making sure the infrastructure is scaled, it is secure, and it is performing well to serve the consumers. With Snowflake, because it is a managed service, right, there is no complexity that you need to deal with. For example, infrastructure, something as basic as storage and compute. And I'll give you an example, right? When you start thinking about storage, I told you that you can scale. So maybe I've got 50 terabytes of data today that I want to put on the cloud or a warehouse. I do that. Now tomorrow, if I want to scale out to a petabyte of data with an on-premise system or something that needs planning, I need to sit and define what kind of storage will I need, how do I ramp up, when do I plan, because storage arriving in my data center, racking, stacking, all of that is going to take time. With Snowflake, I just pump in my data. I don't even think about things like data vacuuming, indexing, how do I place that data into specific folders, partitions, because all of that is completely managed by Snowflake. So you don't have to think about how do I make my query more performant, which engine should I tune. This is again taken care by Snowflake. So the ability to abstract all of the complexity and make it easy for you to consume and make you focus on the data is what the platform does. It is completely self-managed, and again, it's a single platform for you to manage. Whether you're comfortable with a particular cloud provider, could be AWS or Azure, when you log into Snowflake, you log into Snowflake. That's one consistent experience that you get across different cloud providers. Next up, we'll talk about the ability to be programmable for the platform. And again, this is super critical because while you've got data, what do you do with that data? You manipulate the data so that it can be fed to the consumers. Now, again, for a long time, given our lineage, a lot of the consumers of the platform were comfortable with SQL because it was a warehouse, you would deal with structured data, then came in semi-structured formats like JSON and so on, which we could still access, and we can using SQL. So you don't need to do something special to go and access JSON data. I could literally query JSON data as it is, even without flattening it, using SQL and derive some insights out of it, right? And then if I decide to convert it into a structured format, I could flatten it, do joins with other data sets and so on. So SQL was and still is very, very popular from a skill set standpoint. Having said that, when you start thinking about other workloads like data engineering or data science, those teams are not very comfortable with SQL because they need to transform a lot of their data. They need functions, they need capabilities that are more functional language types, which is where there was the advent of Python, Java, and Scala when it came to manipulating data for data engineering pipelines and data science workloads. And this is something that we support out of the box. This capability is GA today. And a simple example is that we run a Python engine inside Snowflake using a developer framework called Snowpark. And this actually allows you to run your code inside the Snowflake platform. Now again, a simple example, right? If I want to manipulate some data, today there is this data platform, which is Snowflake, and there is this Python that is running outside the platform. Now what you want to do today is transform that data, but what you have to do is take that data out of the platform, run some Python code against it, and write it back to the platform. We said, why can't we get the code sitting right next to the data, so you don't have to do this hairpinning of data? And that is exactly what we did with Snowpark. We give you the ability to run your code inside the Snowflake platform. So it's much faster, it is secure. We announced our partnership with Anaconda, which is one of the largest providers of packaged Python capabilities, and that runs inside Snowflake today, right? So this is completely programmable. We acquired a company called Streamlit last year, which gives you instant capabilities for visual data exploration. So you could build very rapid prototypes to build out models, look at what your data looks like, build widgets, and start visualizing your data, right? Then we start talking about the final tenet, which is the marketplace. This is what makes Snowflake the data cloud. So when you talk about the marketplace, it's all about, yes, having your data in one place, but also having the ability to collaborate, distribute, and monetize your data. The first thing is collaborate, right? How do I make sure that my data, let's start within the organization, is available to all different units? And I think there was again that question around centralized versus decentralized and so on. Today there are patterns which we call data mesh, for example, where there are domain-based warehouses or domain-based data structures which can start exchanging data amongst each other. How do we make that architecture far more simpler? Collaboration, right? We talk about private listings, which give you the ability to share that data within the organization. Then start thinking about second-party data, which you can just share, right? If there's a Snowflake customer on the other side, or even if the consumer is not a Snowflake customer, they can still get access, governed access to that data. And this governed access is instantly revocable. So if I want 50 of my suppliers to have a copy of the pricing table, right? I can just do it at the click of a table. There's no sharing of spreadsheets, there's no building FTPs, none of that, right? So it's very, very simple and elegant. And finally, you have the ability to pick out data sets which you believe will be useful for the rest of the market, and you can put them up on the Snowflake data marketplace so that you can start thinking about monetizing your data. With that, a quick look at the marketplace. My second last slide, I know the bell is ringing, but you've got some amazing data sets, you've got some applications, and you've got data services. There are close to 260 providers, 1,300 plus listings of data ranging from demographic, health statistics, climate, all of that, financial data available on the data marketplace for you to download and consume, right? And this data is instantly available inside your Snowflake account. With that, and my presentation, I know there's no time for Q&A, but I'm happy to catch up.
We still have 2 minutes for you.
We do?
We'll take
Wonderful.
one. Yes.
Hi, good morning, Murad. Good morning to all the erudite leaders from the industry. I'm a part of the JP Morgan group, a part of the asset management business. Pretty relevant, amazing journey you took us through. I personally felt like a boy lost in the candy store wants everything. But, one of the prime reasons I'm raising this question is, and you must be hearing this from your clients, more like, pretty monotonous for you to answer, but where does one start? We accumulated a lot of tech debt. Multiple data warehouses on-premise, spread across regions, a cobweb of processes around. Where does one really start? And that is one of the reasons why the leaders usually shy away from even starting off. So if I could get your insights on that.
I'm going to take some inspiration from the previous presentation that was done. I also end up saying this to a lot of customers, focus on the outcomes. Don't boil the ocean. Focus on a few outcomes that are super critical for your organization, and actually start small. We've had customers who wanted to go big bang, will get rid of all those silos and all of that. The ability to demonstrate small wins is critical in that journey. So pick ones that are high impact, pick ones that you think you can consolidate. If you've got 15 different warehouses sitting in your organization, my suggestion is do not attempt to do it all at once. Pick 3 that are super critical, that will have high impact, high visibility. Say that here's the timeline, here's what I will achieve as an outcome by consolidating these into a modernized data platform. And then build out a journey, build out a phase plan is my suggestion.
Yes.
Thank you.
I completely allude with the gentleman. So where do we start? But now coming into the maturity of it, I think there were a couple of buzzwords that I heard about: data democratization, monetization. Now the leap is towards tokenization of data. I think getting rid of silos is one side of it, but how do we really tokenize the data? Is the unit completely matured towards it? The second thing you mentioned about was the third-party data, right? Within R&D, that means within the pharmaceutical industry, we deal with varied type of data. We have our own mesh, which is medical subject heading, but each medical agency has its own ontology. It has its own way of where the mesh terms get interpreted. And each pharma company has its own data dictionary and cataloging. How do you join the dots from these two? If you can enlighten us on that, that would be really great.
Sure.
Thank you.
Sure. I'll try and give some crisp answers. The first one is around tokenization. Yes, absolutely critical. If you're in a regulated industry, you're dealing with IP. That's data that you want to store in a common place, but you want to make sure that it is tokenized. To keep it short, yes, the platform does support tokenization, and it is increasingly an area of conversation that we are getting to with our customers as well, right? So absolutely supported with Snowflake. External tokenization is what we call it. On the other hand, when you're talking about everyone in the industry having a different format, how do we share data, a data catalog, all of that. Again, one of the ways to solve this is have some sort of a common definition, and which is where possibly the Snowflake data marketplace could help to an extent, right? Because when you put up data, you define what that data set is all about, and you also provide some sort of a dictionary to say, here's how you access that data. And we make it simple, right? We say, here's the data structure, and here's how you access that data. And we make it instantly accessible. So we are actually looking for customers, partners to onboard that data. You saw the number of data sets there, right? Close to 1,300 plus listings, that's massive. And once we get to India, I mean, it is what we call the India scale. So once you start having these different data sets on the Snowflake data marketplace, with, very importantly, the appropriate governance rules, so that you are confident that the data that are put on the marketplace is secure, then you can start thinking about some level of commonality from a data definition standpoint. But I agree, it's not an overnight thing, right? It is something that needs to be thought of as a change.
Murad, we need to answer this one quickly.
I will.
Hi Murad.
Yeah, hi.
My name is Sumit, and I came from 𝗵𝗼𝗁, where I'm working as a principal architect. So my question to you is, like, you touched upon cloud agnostic, right? So you can run on multi-cloud, cross-cloud. So to what extent? For example, we have presence on GCP, we have presence on Azure, not on AWS, but we also have a private cloud. So our workloads run, we are actually trending towards more of a edge analytics, right? So
Sure.
our business is more like fragmented business. We have regional deployments regulated, and so we have systems which are installed on different geographical locations, not on cloud.
Yeah.
It's basically a Kubernetes based system. How close you are to enable us for the data analytics journey?
I would say somewhere away, you heard me talking about the ability to access on-prem data. That's an announcement that's been made. So as long as the data is, the data store is S3 compliant, it's an object storage, we've made that announcement, we will have the ability to access that data. The compute, the governance engines will still be on the cloud. But if your data is present on the cloud, we can always access it. And like I said, it's multi-cloud. Now what happens is that not everyone is ready from a data source standpoint, like you said, right? There is computing that happens at the edge and so on. But the ability to build data pipelines with our partners like Fivetran, for example, right? And get that data flowing into Snowflake regardless of the region, right? You could be on GCP, you could be on AWS, Azure. Just get data into Snowflake if the objective is to keep it into one place and provide insights on that data. If you are asking if I am available at the edge as a Snowflake platform, no, we're not.
So we are actually going towards that, and I'll just definitely try to connect with you offline and then discuss further on that.
Hopefully with that stuff that I spoke about where we access some on-prem data, but it's an announcement for now.